Okay, this is problem number 6 on the back of the worksheet titled Test Number 1 Retest Review page. Actually, I'm on the back, so it's page 2. It says Test Number 1 More Area Retest Review. That's the title of the worksheet. Though we're not taking a test, we're having a quiz over it. It's just something I had from another time that I worked at a different school. Okay, so this we know on this, they've got a triangle. It says it's a regular triangle. That means it's an equilateral triangle, which means all the sides are the same. Okay. So now what they've given me here is just the perimeter. If the perimeter is 42 square roots of 3, I can find the side of this triangle. So let's see, that might be the first thing I think to do. If I take 42 square roots of 3 and divide it by 3, remember we're only going to divide the stuff that's on the outside. We don't divide inside a radical with a number outside a radical. So 42 square roots of 3 divided by 3, 42 divided by 3 is 14, and then it's square root of 3. So one side would be 14 square root of 3. Now that's kind of good because, you know, you might think you could do the formula area equal 1/2 base times height, because if you know the whole side's 14 square roots of 3, you know that's half of a side, right? So if the whole side is 14 square root of 3, the half of the side would be 7 square roots of 3. But unfortunately, you can't use the area equal 1/2 base times height formula. You might know the base is 14 square roots of 3 if you look at a whole base. The problem is you don't know the height. The reason you don't know the height is that this little piece they gave us right here is the apothem. And when I see that drawn on, most of the time I need to use the area is 1/2 times the apothem times the perimeter formula. And they actually gave me the perimeter. It was 42 square roots of 3. I just was messing with it to find out the length of the side because I figured I might need to know that. So the reason I can't use this one is I don't have the height. Some people say, oh, but you could just find that apothem and double it and you'd have the height. But that's not true because the apothem is from the center of the circle to a side. It's a perpendicular length to a side, whereas you might think it's about half of the height, but it's really not, because if I drew another dotted line up here, that's not another apothem. That's actually a radius of the circle, so I can't really do that. I'm going to actually take those dots off there if I can get it to disappear. I'm trying. It's just not responding very well. Okay, so what I have to do is I have to look at this right triangle, because if I'm using this other formula, all I need is the apothem, and the apothem is just this side right here. All right, now I know that a whole side is 14 square root of 3, so half of a side would be 7 square roots of 3, and that's this piece right here. If I think about it, I know what kind of triangle this is because the one angle in a right triangle, in an equilateral triangle, is 60 degrees, but the radius of a triangle cuts that 60 in half. So this is a 30-degree angle and this is a 60-degree angle. So let's label this. I don't want to use A's because A's would make me think I was talking about my apothem or something, unless it just accidentally works out. Okay, so I'm going to label with X's here just because I can, okay? Across from the 30 degrees, that's X. Across from the 60 degrees is X squared to 3. Oh, I know what X is now. It is 7. That's what my apothem is, so it's 7. So I'm going to put a 7 right there. And now I'm just ready to multiply out. Some of you kind of asked me, is it okay if I rearrange the terms and say 1/2 times 42 square roots of 3 times 7? Yeah, sure. Because multiplication, we can take 3 numbers and multiply them, and it doesn't matter if I switch the order up. I'm going to get the same result. So I like to do that, actually, because I like to say 2 goes into 2 once, 2 goes into 42 21 times. So 21 times 7, because those are the only numbers outside the radical right now, would be 147, and then square roots of 3 would be our answer. So yeah, the 1/2 base times height would not work unless you want to find the length of the radius and then add it to the apothem to get your height. You could make it work. It's just going to be more work to do that than it is to actually go ahead and solve it with the apothem. Okay, so let's look at problem number 7. Problem number 7 is a square. Squares tend to be a little easier to work with, even if they give us an apothem, and that's what they actually give us here. Oh, no, they don't. Almost. They draw this in, and they tell me this is a radius right here. That's 8 square roots of 2 inches. Now, I got a right triangle, so when I first look at this problem, I think the easiest way to solve this is going to be area, is to use this formula, a half apothem times perimeter. I'll talk about the fact that you could actually solve it a different way if you wanted to, but it's going to be about as much work. Okay, so what kind of triangle is this? Every angle in a square is 90 degrees, and when this radius comes into this 90-degree angle, I'm going to change colors. When the radius comes into the 90-degree angle, it actually splits it in half. A radius splits an angle in half. So 90 divided by 2 is 45 degrees. So I have a 45, 45, 90 triangle. Across from the 45, I could label that A. Across from this 40, I probably should not pick A because A is the apothem. Across from 45, let's just call it B. Across from 45, let's call it B. And across from the 90-degree angle, it would be B square root of 2. Now, they told me that that little radius over there was 8 square root of 2. So I can see that B is 8. That makes that side 8. It makes that side 8. So my apothem is actually 8. 1/2, 8. And the perimeter, okay, let's see. That side was 8 and this side was 8, right? This green side I'm drawing on. Now that's half of one side, right? So if I look at a whole side, it would be 8 plus 8 is 16. So one side is 16. So if I want the perimeter would be 4 sides that are 16 units long. So that's 64. Okay, so there's 64. All right, half of 8 is 4, and 4 times 64, I'm trying to do this without grabbing a calculator, would be 256. So my area is 256. Now notice that in the course of doing this, you figured out what one side was. It was 16. So yeah, at that point, you could have come off to the side and said, oh, the area of a square is just the side squared. Okay, well, one of the sides, I just found it. It was 16. Well, 16 squared is 256. I don't care which method you're using because a lot of times you could go either way on it if you just do enough work. Usually there's one way that shows itself to be easier than another way, but in this case, you might have stopped here, and squared it and said, I'm done, and that's fine. I really don't care. That's part of just knowing what tools you have to use them and which one's the easiest to use in a certain situation. I'm going to skip down to number 9 because we've had a lot of squares, and I felt like, we've done a lot of work with squares, so I kind of would like to just skip that one. Just a hint on number 8. The perimeter's 20. That means each side is 20 divided by 4 would be 5. Actually, I can just write it down real quick and get you going. Since the perimeter's 20, each side would be 20 divided by 4 is 5. Find the length of the radius. They want this length right here. I'll highlight it. Since each side's 5, this little half of a piece that I'm highlighting in red is 5 halves or 2.5. So, or you could either call it 2.5 or 5 over 2, right? Either way. And you got a 45, 45, 90 triangle here. So if I want to know this side, it's going to be A squared root of 2. This is A, and you can tell A is 5 halves. So if you want the length of the radius, it's just 5 halves times the square root of 2, or 2.5 square root of 2. So actually we did 8. No, 7. This is actually 7 that I just did. Okay. Moving on, let's do 8. Okay, so I messed up. That was 9. That was 8. We did 7. We did 8. Now we're on 9. Okay, I'll get it straight eventually, guys. Sorry. Okay, so I have a hexagon. And they draw in a radius and the apothem, so I know I got that going on. And they tell me the sides are 4, so I know that all the sides are 4. Because they drew the apothem in, and because this is a hexagon, I can find the area using that area is equal a half apothem times perimeter formula. Well, I just really need to find the apothem because the perimeter's not too hard to find here. The perimeter's going to be 6 sides, and they're all 4, so it's 24. So if I find the apothem, I'm going to be done, okay? So there's a right triangle in there, and we kind of need to solve it. We know that if a whole side's 4, half of a side, which would be about that length, and I'm making it green, I'll make it down here on the bigger triangle, is going to be 2. But I don't know what kind of triangle that is just quite yet. I can figure it out. If I just knew what one angle in a hexagon is, I could divide it in half and get that angle that I just put a green dot on down there at the bottom. So here's the formula. We got to remember we do have a formula that helps us with that. It's n minus 2, number of sides minus 2 times 180 divided by n. There's 6 sides in a hexagon, so that's 6 minus 2 times 180 divided by 6. Well, 6 times 180 is 1040. Oh, wait, that's not 6. 6 minus 2 is 4. 4 times 180. I forgot to subtract before I multiplied. 4 times 180 is 720, and 720 divided by 6 is 120. So one angle in a hexagon is 120 degrees. If that radius splits that 120 degrees in half, that makes this angle down at the bottom 60 degrees, so the one at the top is 30 degrees. So I can label my triangle now and find my apothem. Across from the, I'm just going to use x's to label. Across from 30 degrees, label it x. Oh, x is 2, okay? Now I really am interested in the apothem, which is this red side I'm drawing in right now. Across from 60 degrees, that would be x squared root of 3. Oh, but x is 2. So the apothem is 2 squared root of 3. That's really all I needed to finish this problem. A half times 2 is 1, so those kind of cancel out and make a 1. And it's square root of 3 times 24, so the answer is 24 square roots of 3. Okay, so lastly, number 10. This is a kind of a thinking problem here. They tell you you've got a rectangle that has the area of 155 square units. Let's draw a picture of it, which is what I've already done. I drew a rectangle. And the formula for a rectangle is most of the times we say base times height, but we could also say length times width. And because they're using the words length and width in the rest of the problem, I'm going to call it length times width. So now they're going to change the rectangle. Draw a picture of what they're doing to change it. It'll keep you on track. So here's the original is the red. My new rectangle is blue. Okay, so they say the width was doubled. So here's the old width. They're going to double it right down to W. And the length was tripled. The old length was L, so I will call this 3 times L. Okay, so if I want the new area, it's its length times its width. It's just different now. Its length is 3L and width is 2W. Well, 3 times 2 is 6, and then I've got L times W. Now, this old area was 155, but remember, length times width is 155 from the first problem. So when you multiply the length and the width, you get 155. Look right over here where I'm circling in yellow. There's length times width. So it's 155. I'm just going to take 6 and multiply it by 155, and I would get 930 units squared. So what would be the new area? 930 units squared. You can actually just use these formulas this way, and since you knew what length times width was, you stick it in there, and ta-da, you're done.